So figure 3 shows a small aircraft being used for a tow glider. So we've got a cable that we can see here with the tension force, and the tension in the cable is 2,000 newtons. So I'm going to write 2,000 newtons just here to remind me. And we can also see that we've got a 20-degree angle. So what we need to do is draw a vector diagram to determine the magnitude of the two components of the tension force in the cable. So what I've done here to start with, and I've got my protractor ready, is I've measured 20 degrees just there. Now somehow we need to make this equivalent to 2,000 newtons. So what I recommend doing with another ruler is to make that 10 centimeters long. So when drawing it to scale, you can then make that 10 centimeters long and doing it quite accurately. Once you've done that, you need to complete the triangle. So again, use a ruler and draw down. And what we're trying to find is the horizontal component. Well, the horizontal component is this one, so that's the length of that. And we want to find the vertical one, and that's the length of that. So what we would do is we'd get a ruler, we'd measure that, and the vertical, measure that as well. So let's do that now. I've done it quite quickly, but I've got 9 centimeters and then 3 centimeters. But now we need to scale it back up again to 2,000 newtons, equivalent to 10 centimeters. So then 1 centimeter, if we divide by 10, equals 200 newtons. So I've got 9 centimeters just here. So I need to multiply that by 200. So 9 times 200, that's going to give us 1,800. And this one will be 3 times 200, that's going to give us 600 newtons. Now you are allowed a little bit of margin for error because you are using a ruler and you might make a mistake, but for the horizontal component you had to measure between 1,800 and 1,900, and for the vertical it was between about 650 to 700. So doing it on the computer here, I've made a slight error just there, but hopefully you've got the right method. Now, of course, you could have done this with SOHCAHTOA, so let's just look at that. So I'm just going to clear the whiteboard and we'll look at the SOHCAHTOA method. So first step, let's label the sides. So always go for the longest one first, the hypotenuse. The one opposite is opposite and the one next to is adjacent. So if we wanted to find the horizontal components, that's going to be looking at this one and this one, because the hypotenuse we know 2,000 newtons. So SOHCAHTOA, so hypotenuse and adjacent, that's going to be cos. So cos theta equals adjacent over hypotenuse. We want adjacent by itself, so then that's going to be cos theta times hypotenuse equals adjacent. So cos 20 times 2,000 equals 1,879 newtons. And then to find the vertical component, we need to use sine, because that's opposite and hypotenuse. So sine theta equals opposite over hypotenuse. So then the hypotenuse times sine theta is opposite. So opposite equals sine theta times hypotenuse. So sine 20 times 2,000, and that gives us about 680 newtons. So as you can see, far more precise using SOHCAHTOA, but it can be done just about using a ruler and protractor if you need to.